I may not be here the entire time.
Oh, okay.
Tony volunteered.
Tony.
It's a miracle.
Okay.
It's a miracle.
Tony, did I see that time now?
Now we have to ask ourselves, is this what we really want?
I was actually.
Outcomes may be different than what was reported.
Yeah, I was actually wondering, like, do we now bend reality a little bit? Rewriting history.
Commence.
Okay. Maybe we should start. Okay, so I just got my first slides. Give a second. Maybe you can want to say some introductory words. Yeah, on this.
Okay, so we have our minute taker, our Travis Scott, thank you for volunteering, we appreciate it. We are here for Oauth. If you are here for some other meeting, I suggest that you will be bored out of your mind and you might want to find another place to be, but I'm just here to talk about Oauth. I'm Derek, this is Thomas, and we are your co-chairs. Thank you for coming. As people say, note the note well. I'm not sure this probably will.
No, that's your source.
That's me. Well, yeah, what's missing? So this is our agenda. Kind of a conflict. We have a 2-hour slot. Anything else with it? Hopefully. And any changes to the agenda?
Yeah, we have Sean to talk about different cases based on a blog post of the proof of possession token based on what he wrote as a blog post. I think that provides a little bit of background where we are.
So current work group status.
Yeah, so Kathleen, correct me if I'm wrong, but for a couple of the documents we are pretty far along. So the first 4, the overall assertion framework with the GWE bearer, the standard bearer, they are in RFC editor and RFC editor 2. The same is true for the JWD, which is great. So got some work done. Always takes a little time to produce through that process, but now it's happening. And then we have 2 documents in ISG processing, also look very good. The dynamic client registration and the management document work. So thanks for all the work. And then we have a few other documents that are close to leaving the working group. The first one is the document that was formerly known as SBOC, this proof key for code exchange. And I will use the time to work with Nat to get the Shepherd write-up updated. There were a few things missing, and talk with Kathleen about that. But I think from a working group point of view, it was pretty much done. So we had working group last fall. We went through it. I did my Shepherd review on this, and so I don't remember any open issues. So that's good, just to get the Shepherd right up. Then there's the proof of possession architecture. We did the working group last fall, so we did an update, and we'll work with Derek to get the Shepherd right up done, so we can send that. That's an informational document. The proof key document was a standard spec document. Derek also issued the working group last fall for the proof of possession semantics, which is the first standard spec document in his proof of possession track. And the working group last fall runs till tomorrow, so it would still be good to get some reviews in. Initially, we were worried that nobody has read it, or so it's not a very complicated specification, but Brian submitted something and we have a discussion later on about it.
So the quick show of hands, how many people have read the draft? And how many people intend to read the draft before the deadline tomorrow? Okay, what's the key one?
Yeah, it's a simple specification, but it would be good to get more folks to review it. And then there's also the document inspection, which we had a working group last fall a while ago, and just responded to those comments, had some back and forth, and need to finalize the Shepherd write-up. But we also have a presentation on that topic, so we have a few things to discuss. And then we have a few documents that are still work in progress in the group, and we'll also discuss them later in subsequent presentations. Okay, I think Justin, could we start with the document?
Yeah, sure. Okay.
Well, it's brighter now, so that's good. There we go. All right, thanks. Next slide. So we've done a handful of changes since the last working group last call. There have been a couple of small normative edits. We removed resource ID because it turned out that nobody cared about it, nobody was using it, and it confused the people who were reading the document, so we chucked it and nobody cared that it's gone, so that's good. We added privacy considerations in there, which I'm still getting used to adding into documents now. We added a lot of text based on discussion with Hannes, Tony, and others on the list about what it means for a token to be active, and you guys will see that in the new version that was just published this morning. When tools opened at midnight, I submitted the new text. So there's a lot more text now about what active actually means in practice. It turns out that this is a little bit, it's a little bit fuzzy to try and specify that because the nature of Oauth, a token could be active basically however the authorization server wants it to be active. So worked with Hannes and we came up with some text that says basically if your tokens can expire, then you must check if it is expired or not. If your tokens can be revoked, then you must check whether it's been revoked or not. To give implementers of authorization servers guidance about the checks that you have to do and give resource servers who are depending on this protocol some assurance that somebody who is claiming compliance with the specification that the authorization server has done its job. We cannot, however, go far to say these are the checks that you must do in all cases because OAuth tokens have such different properties in different deployments that we can't prescribe the whole list. So please read that new text. I think it's pretty solid, but if there are even a couple of more bullet points, standard checks that other people have done in their implementations, let me know. I base this off of my implementation and a couple of others that I've seen, the checks that we do, so please let us know. I did in the last draft, and this is something I'd kind of like feedback, we changed the user ID field to username. There was one extant deployment that was using that, and I pinged them, and they basically told me, yeah, that won't be that big of a deal. We'll probably, in our implementation, keep the old user ID field as a fallback for now, kind of thing. So I think we can move that forward as kind of a little extra thing. Mike made the point that it semantically really is a username and not a user ID, and I'm fine with that. So if anybody objects to that change, please let us know on the list before we solidify this, because I do realize that this is a late stage change of the name of a parameter. And we updated all the references, so we're pointing to the correct version of HTTP and TLS and all that other fun stuff. Next slide. There's one big open issue right now, and that's how do we deal with the registry? Now, we basically have two different ways, and this is all covered in the introduction of the introspection draft. We've got two ways in use in practice today to carry information about the tokens themselves, either in the token itself or by reference through a service call like token introspection or something along those lines. So what we've kind of run into is that Jot got here first and defined a whole bunch of things like the expiration field and the not before and subject and all that kind of stuff. And that's all great. But when we first did the introspection draft, we just made up our own field names for all of those. Somebody very rightly pointed out, well, why not use the same fields when we have the same semantics? Why does token introspection say expiration and Jot say EXP? So we decided to just adopt and incorporate all of the Jot fields. That's great. Moving along a couple of drafts further, somebody said, well, why not just use the Jot registry directly? So we're like, yeah. So we thought, all right, that might work. And then the next step was, well, since you're using the Jot registry for those, why not register all of the token introspection parts into the Jot registry? And that's where we are with the current draft right now, and that's where things are starting to fall apart. Because there are fields in that are very, very vital to a token introspection API, active being, sort of the biggest culprit here, that make absolutely jack all sense inside of a Jot. Because why would a Jot claim to be anything other than active? Think about that, right? So it turns out we've got kind of these two uses that are doing slightly different things. So I've come up with 3 different ways that we could potentially move forward. There are probably other ways as well. Next slide, please. Next slide. So the first is kind of what we have today. And Mike's already shaking his head. For those in the Jabber chat room, make sure they know. It does give us the niceties of automatic deconfliction of the fields, so that we're not stepping on Jot claims and vice versa. There's only one list to check for all possible values, though no developer that I've ever met actually checks IANA registries, but that's another story. However, the con is, and this is a big con, is that the fields don't really make sense in both places. So having one list apply to both places doesn't really work. We could, however, as a workaround, alter the Jot registry, and I realize that Jot is like way out the door at this point, with some type of indication of the target for it. Maybe we can tweak IANA to do that, I don't know. This is kind of a brainstorm. It is? Okay. Okay. Okay, excellent. So I wasn't sure if that was even possible, let alone desirable. Next slide, please. There are a couple of different ways we could do this. Next, we could go back to what we had in the first place, was to make introspection its own separate namespace. Now, this is actually nice from a developer and kind of a spec cleanliness standpoint, because everybody gets their own namespace to play in, they define their own things, and you can have things that make sense in Jot that only make sense in Jot and in introspection and vice versa. However, if you are defining something that is useful in both, you do have to do the footwork to make sure it gets registered in both and it's got the same semantics in both. Otherwise, that's going to be very confusing for deployments and developments. And it does give you 2 lists to check for people that actually check IANA. We could, however, and we kind of thought about this when I was talking with a few people in an earlier version of introspection, is that we create a new registry but seed it with everything that's currently in the Jot registry, just kind of pull it in wholesale and dump it in there. Next slide, option 3. I have no idea if this is possible, so IETF wizards, please let me know. is that we create a new registry for the introspection only stuff and then normatively reference the JOT registry for the JOT stuff. But, and this is a very important but, we would have to make sure that they don't step on each other, because we are defining a process whereby both of them are used within the same namespace. That feels really funny to me, to have two IANA registries used in the same namespace. It's kind of counter to what the structure is there for. We could do things like make sure that the reviewers know about this, but this to me feels like it's a little awkward as well. So there's not one of the three options that I think is particularly a clear winner, but we need to pick something to move this forward.
Just to put it out, I have to talk to Michelle and see if this is possible.
Right.
It may be, but it may not be.
Right, yeah, that's,
It might be better to go with the first option with the extra columns than this.
okay.
Because I know that's doable.
That is doable, okay. Even with JOT at its stage, even with JOT at its current stage, we can change its, okay.
Mike Jones, Mike Rizzo. I would advocate option 2. It is clean and it's much more like what we do in other places. So for instance, dynamic registration has its own registration and registration.
Mhm.
It's possible that somebody could use some job values in there, they could register.
Mhm.
Likewise, he suggested you could import the job names into the introspection register. Where they make sense, just do that. When there's language, you could cut and paste,
Right.
saying this is that, and it's going to confuse nobody. But you're not going to end up in a situation where option 3, if somebody finds something as a JOT claim that makes no sense for introspection, you don't want to just automatically conflate the two things.
Right.
I think when things are different, put them in different lists.
Mhm.
And when they're the same, explicitly point them. And I think that's clean.
Mike, I think it's possible to have the case where name in the introspection document makes no sense for JWT, but I don't think the other way around is really possible.
We haven't come up with that use case yet. I was trying to brainstorm to see if there's, I'm not willing to to put bets on with that being impossible yet.
There's gobs of claims in Active Directory that I'm sure would make no sense under inspection endpoint, but
Mm.
which is perfectly legit to pass in a job.
So
Right.
I have please stand up, stay there. I have another one more follow-up question, which would be, can you think of any cases where the semantics of a JOT's name versus introspection name is different, but we want to have the same name? And that's the case, that if the answer to that is yes, that would definitely show that I'm going off the Uber document. And if the answer to that is no, then it's still a viable option, but it doesn't get ruled out immediately. So if the semantics be different, then obviously we need separate registries. If the semantics are always going to be the same if you have the same name, then we could still theoretically combine them and just have a separate file for use case.
There's different hats to look at this with. From an introspection hat, it kind of doesn't matter a lot which of these you do.
Right.
If you're just a developer using JOT for something else completely different, and they do check the registry, it'll be more confusing if there's stuff that's not related to their use case that they have to figure out to ignore. And I'd rather we just
Yeah, I can't think of any cases where the semantics would be different, but again, I'm not willing to kind of place bets on that based on the current family of JOT stuff. The question was, isn't expiration one where it's different? And no, because it's when the token will expire in both cases. Microphone, if you're going to. Let Brian be rude and jump the line, please.
My question was semantically, I feel like expiration are somewhat different, where in JOT, it's the expiration of the token that on presenting the receiver should not accept it after
Mhm.
Where in inspection, it's more of, I presume the authorization server is actually checking the expiration and returning the expiration in the return of the introspection request is more of a hint to the client or the resource server in this case about how it can cache, how long it can consider using this token. So they mean sort of the same thing, but they're
No. So in implementations that I've seen, including our own, it's actually the same value. So the value that's coming back from token introspection is this token will expire at this point. You can use that to inform your caching decisions. And so there is new text in the draft that was published this morning that clarifies all the caching stuff. So there's a whole paragraph in security considerations about exactly what to do with caching, because we're not going to solve cache consistency here, I'm sorry to say. But it is not actually directly a hint for what to do with caching. It is very much the timestamp of this token shall expire at this point.
So would an authorization server return a response to an expired and is it up to the resource server then to enforce that?
So no, actually, because it would be active false.
So they are semantically different. The way that
The value means the same thing in both cases. Is it? Oh, it's not. Okay.
it's switched to on, but there's no.
All right. Okay, so in the meantime, we can use this for the floor mic. Oh, John's got it.
The battery died.
Stop sending.
Yeah.
Anyway, I see kind of where you're coming from. It's sort of an esoteric point, but I guess I'm just driving to that there's a lot of differences, and I think it suggests that two independent registries are maybe the way to go with this.
Okay.
In a case like this, where there is maybe some confusion even around a well-understood claim.
Okay, that's fair, and that does lean towards option 2 and importing JOT. Which, for the record, honestly, I would be fine with any of the 3 options personally, because introspection, I don't think much cares as long as the values are available and defined somewhere as a protocol. I don't think we care. This is a sort of process cleanliness question. John, you've been so patient.
How unlike me. John Bradley Ping. So I do agree with Brian that there are some subtleties between the potential definitions of some of these claims. I think the bigger issue for me is setting a precedent. If the JWT registry becomes the place where everyone deconflicts every claim name in every JSON object, then it may become significantly less useful for JWTs. So I don't really want the JWT registry to become a dumping ground for everyone deconflicting short names. I think that there probably are some subtle differences, but having a separate registry and importing the names from JWT where it makes sense is, I think, the cleanest thing to do.
Okay.
Okay.
Mike's good.
9 minutes. I will ask 3 questions. I would like to find out from you in the room of which of the 3 options you prefer. So let's go back to option 1. Raise your hand if you are in favor of option 1. Okay, nobody.
Are we doing hand raises or hums or hand raises? Okay, just making sure. That is why I was asking. I wasn't sure. Okay. The AD says we're good. An adult told us we're fine.
Okay. And only one thing. And who's in favor of option 2? Raise your hand.
so we have clear consensus in the room, we'll take that back to the list of their comments.
All right, so what I will plan to do then, as editor, is push another version of this with option 2 implemented and bring that to the list for kind of a final discussion so that people can see what it looks like in template.
Yeah.
Okay,
Excellent.
sounds good. Thank you. That's all I had on that.
And once we get that done, and have to ship it right up, finalize, then we send it to the IETF.
Sorry, I was kidding about the last name. So we're in last call on proof of possession semantics for JOTS. As our esteemed chairs have already indicated, the last call will expire tomorrow. People woke up yesterday, I think they used the flight or their insomnia here to file a bunch of good comments. Particular thanks goes to Brian and Matt and a few other people. I think they're all ways to improve the text. The effect of all the comments that I've read, I've not done a thorough review yet, seems to be local. There's no architectural changes. So I propose that those who care talk both among ourselves here and on the list this week and sort out resolutions for those comments, publish a new draft, and chairs take it from there. Yeah. Stand and deliver, Brian.
It's Brian again from Ping. As Mike said, I was waiting for a delayed flight and finally had a chance to read through this and send some comments. A good number of them are sort of just editorial meh kind of things that maybe should be looked at but aren't a big deal. There may be two sort of substantive comments that I did have, maybe more. I'm trying to work from memory. Maybe the biggest and most recent one, I think, is that the current draft has conf CNF as where its value is a JSON object, and it talks about that's sort of supposed to be analogous to SAML's subject confirmation element in that it allows for multiple confirmations to be included. And I noted that it's not, as it's written now, it's not really analogous to SAML because you can have more than one confirmation of even the same kind, and the data structure right now doesn't really allow for that. So if we wanted to make that comparison and make it sort of feature-wise equivalent to SAML, it should probably be something more like an array value with multiple comps allowed. Having said that, I'm not sure that's worth the complexity that's involved. And I would actually, I think, prefer to see it maybe move the other way, which is to simplify and flatten out the whole thing, and rather than having conf with, I'm not sure how we're supposed to say that, CNF with sort of sub-members underneath it for different types, maybe flatten out the whole structure and have individual named claims for the various confirmation types. I think gets us to the same place that the draft is now, and is a little bit more compact and arguably a little bit simpler.
So just speaking as an individual, to your first point about arrays, you know, gosh, when we invented JOT, and a bunch of us in the room did, one of the big inputs was SAML and how it's actually used. And we thought about, you know, what are the 80-90% cases we want to write down and make them dirt simple, and what is the stuff that's possible but that we can leave out and use registries to extend if you need the functionality. And we landed where we are. People seem to like it. And so with confirmation, I think John and I and a few others kind of did the same thing. We said, some of this is used. Let's have a way to write it down. But let's not go whole hog. And there's a registry for people to go whole hog in specific ways if their business case requires it, and that's great. So if you needed an array valued claim, knock yourself out, make one. As far as flattening it, I've heard that feedback more than once, but there's a bunch of cases where, in fact, you do want the same claim name because it means the same thing in the confirmation structure and in the top-level structure. In particular, right now, there's a key ID potentially in the top level. There's a key ID in the confirmation. There are different keys. You don't want to invent a different key ID name just for key ID of confirmation. It's cleaner to use the structured nature of JSON and have claims within it, in my take on it. Furthermore, Tony's got a thing in the back of his head, I know, maybe in the front of his head, that what if you wanted a confirmation assertion that is not a JOT? What if it's SAML? What if it's a TPM assertion? With this structure, we've got a registry where we could define, TPM assertion hoo-ha, and life would be good. And I really don't think we're improving things by flattening it.
There's a couple of things.
We could do it, but the result would be we would invent a bunch of claim names that mean the same thing, but they have a conf prefix on them.
Yeah, which I guess is sort of what I'm suggesting. That still feels sort of simpler. Overall, it'll be more compact, and we already have the registry established for that.
I don't think it's conceptually simpler. It's a flat syntax, but I think it's harder to understand because these small number of confirmation claims are actually right now syntactically grouped.
They're grouped together. But I think there's some edge cases then at least that need to be dealt with, like what is a comp that has multiple members underneath it, which isn't really discussed right now, where things like that would be more clearly, they'd be more clearly called out in individual claims.
And that's a good critique. Suggest language and we'll do it.
Okay, but overall, I generally think my feeling is it would be simpler to flatten them out, but I'm curious what others have to say, because I see conceptually where you're coming from, but yeah, when it's an object underneath the CNF, there's room for other values in there that make processing a little bit more complicated.
But at least the use cases I know of, that ability to extend that will get used.
Fair enough.
And thank you for spending the time in the airport doing something really useful.
It's better than a lot of things you can do in the airport. I think the other, again, I'll have to refer to the list, but sort of substantively, the other comment I had was that I found it a little bit odd that we were using the same member name in the conf to represent different data structures. Certainly it works, it's possible, but sort of coming to it from the outside at first, I would have expected a different name for the encrypted key version versus the JWK.
I'm okay with that change. While JSON is polymorphic, it may not help people understand it if we use it that way.
Yeah, and I don't actually use a lot of them myself, but I know there's a lot of tools that do like automatic data binding against the names, and you have to really fight with them to get them to handle kind of polymorphic types in the data binding. Just a thought. So the rest of the stuff I think was just sort of nitpicky editorial stuff.
Which is useful.
Tony Nadlin. The other thing is whether we're going to support multiple keys or not for POP. So there's many cases that we have where there can be, a set of nested keys here.
This is Brian again. That was basically the first point I was making, that we don't support it right now, and that was kind of what's analogous to SAML, and that it seems like the general consensus is that we shouldn't, should not.
We definitely So we definitely have use cases for multiple keys to be used.
Multiple keys here means you have one access token, for example, and it's bound to multiple keys. And presumably it means you present either one of the keys, not all of them.
It could work.
It could go either way, right? So our cases, in a particular cases that we have, we present one or the other key.
And, you know, you and I have had this discussion over lunch, but if the keys have somewhat different meanings, let's give them different claim names within the confirmation structure. If multiple keys are of the same kind, let's have an array claim that we define in another spec and do that.
I guess we would have to see some examples on maybe some how this would look like to get an idea. That's obviously a normative change that we need to discuss.
Well, I think it's a normative new thing which you would add via a registry, and I could write up an example of what a few of these might look like, but I don't think they need to go into the base spec.
Just a kind of a quick follow-on to that. I do think it would be useful to have a little bit more sort of explanation about what is necessary in order to confirm, particularly in the case when there might be multiple confirmation types under one. Is it any one of the above, all the above, application specific? I wasn't sure, and I think there's a lot of issues that come up with it.
If I'm understanding correctly, that may change from usage to usage, and if that's the case, there's obviously an indication needed on whether you have to
Somewhere.
assume multiple ones or not.
Yep.
Okay. Thanks, Mike. So who's going to leave you this document here this week so we can wrap this up? So, Justin, I think Justin, who else? Matt? Anyone else? Justin, Matt? John?
Yeah, so this is a bit old, and having only had decided to do this at lunch, we'll see how this works. Make that bigger because I. Okay, so. Oh. So I started using OpenID Connect as an example based on top of Oauth. So one of the first things that happens is in token binding, but I also have to read it. So the client establishes a key with the authorization server. Go down.
So I think it's worth to add that in this specific case, so that we have two different variants in there, symmetric key-based versus asymmetric key-based, and you're talking about the asymmetric version, which is fine. And in the asymmetric version, I think the word that you described is one where the client generates the public and ephemeral public-private key pair.
Yeah, I think that's the example I used at that stage. So we start off with, so there's two token binding specs, which are here and here. One is the low-level spec, the other is the HTTP binding. So the OpenID Connect client uses the HTTP binding to essentially do a request to the authorization server and include its token binding key in the request. We'll keep going down. So the public key of the TLS session to the client is passed to the AS. So the AS then extracts that and then may also use token binding as part of FIDO U2F or FIDO 2 what is the new spec called? So the FIDO 2 spec uses or may use token binding as one of the ways to protect from man-in-the-middle attacks when doing the actual user authentication. So there's a way of using token binding to protect against man-in-the-middle attacks in the actual user authentication, which is an important step in actually doing in OpenID Connect because you're actually authenticating the user. So you have two different token bindings, one that's happening to the relying party, which then gets passed to the IDP, and the IDP is also using it to do end-to-end security on the authentication session. So it does its normal authorization. Then in the authorization response, we were talking about the CNF element in the JWT. So there's something called an ID token for those of you that don't know in OpenID Connect, which is the JWT assertion. So we put the key that we got in the via the token binding into the actual ID token, which there's an example of it here.
A privacy violation.
So this is an example of an OpenID Connect ID token with a confirmation element which includes a single JWK, which has essentially the public key that was created dynamically for the TLS session between the browser and the client. So as we move on. So the authorization server signs the ID token. getting into some of the finer points of token binding, you may actually want to include both legs of both keys in the actual confirmation element and use a slightly different callback so that you actually do man-in-the-middle protection in both directions. By default, you only get man-in-the-middle protection in one direction to avoid correlation. So that's a token binding issue that somebody is going to have to sort out. So the client, when it gets the ID token, extracts the public key from the element and compares it to the public key of the TLS session that it's gone over. So the client also gets the code, which had a detached signature in the ID token, which is part of Connect. So in order to prevent people from tampering with the code, you sign the hash of the code in the ID token. So essentially, without tampering with code, you've now done proof of possession for code, but through the detached signature in the ID token. If we keep moving down. So the client is going to have its request and access token. The token endpoint returns an asymmetric. So in this case, the client could have pushed the asymmetric key in its request with code, but in this case, we're just going to allow the AS to assign the asymmetric key material in the response, depending upon the algorithm and token type, which is requested or negotiated out of band. Okay, so this is right. Right. So this is an example of response with a unencrypted symmetric key that's contained in the actual token. So the client gets a private key in a separate part of the message and puts the public key, which is not directly related to token binding in any particular way, though in principle somebody could make up a way that it might be. So we can move on.
Yeah, I'm going to talk about this specific
Right.
part of the exchange and subsequent call.
So this is a new key separate from, that's established for the client, which is separate from any of the token binding stuff that happened in the first round of exchanges. Okay, and the key element is either a JWK or a JWE. Wrap JWK, which was the thing that Brian was objecting to. Essentially, at the moment, you have to sniff the content to figure out whether or not it's a JWE or JWK. So Mike and I have agreed to change that into two separate elements. So if we go down here, this is the actual ID token element.
It might be important because that issue, that specific part relates to the presentation we heard earlier. But the notion of the notion of having sort of the encrypted and versus non-encrypted version depends. Of course, you always have transfer layer security underneath, so that whether it's encrypted or not relates only to the content, additional encryption as part of the JSON structure, not whether there's nothing that ever goes in clear over the wire. So just to make sure that there's create a false impression.
Right. So this is the ID token, which is, or it's not. This is the JWT assertion, which is the access token. So this is consumed by the resource server, not by the client. And you can see it has a confirmation element, and again a JWK, which is the public key, which relates to the private key, which the client got when it exchanged the code. So in this example, it got it. There was up in the previous block, in that response, it was assigned a private key for use with this access token, or for use with the refresh token. So the key pair is assigned based on the refresh token, not reassigned for every access token in the draft as it currently is. Then the client uses the access token along with its proof. So here we're using the signed request to, which is Justin's draft for essentially using the private key to sign a new JWT, which is sent along with the HTTP request to sign, which includes a hash of some elements of the message, which is the actual access request. So you can see from this that there are actually a number of different specs that relate to proof of possession. There's PIXI, there's token binding, there's key establishment and actual key access. And the thing that we haven't talked about very much is how we protect the refresh token if it actually needs to be protected. At the moment, we're not doing anything to proof of possessionize the refresh token, based on the assumption that any tokens that are, if somebody were to get the refresh token, since they wouldn't have the key that came back with the code exchange, that they wouldn't be able to use it anyways. But there may be good reasons. If we wanted to actually hand out individual keys for individual access tokens based on the refresh token, then we probably should do something to protect the refresh token. So those are some of the things that we need to think about in that spec. So this is the list of the various things that call themselves proof of possession-ish. So they actually wind up, from looking at it, they don't really step on each other in any way. They all wind up being composed into these larger flows.
And that works.
Yeah.
And it may sound a little complicated, specifically with some of the specifications. So that we saw there's the private egress file in there, and also the new work, the local binding work, and some of the work that we are working on. So there will be lots of different components that you may or may not use together. And open connect as well in this case. So.
Right. So we have to make sure that these specs wind up being composable in sensible ways, and that we don't wind up leaving the back door unlocked in some unanticipated way.
But did that sort of make sense to you, like from a high level point of view? I don't know if we should actually, so we have examples in our documents. The examples are a little bit more simplistic, of course, because they don't take sort of the full blown work into account, but maybe we should actually also cover an example at the level that you did, maybe an appendix to illustrate.
Appendix or a non-spec cookbook of some sort.
Yeah, I don't know. Maybe you can find that useful. Because for someone who hasn't been involved in a working group, it may be a little tricky to find out how sort of these various components, Open Connect, FIDO, etc., fit together to a complete picture. Tony.
Question here, I guess, is are we moving too fast, and should we slow down a little bit and look at what's going on in other areas to get better? You know, I would hate to see it without something that's going to have to be revamped again because of maybe what's going on unavailable or some other groups that are going on. We'd rather see us push back a little bit on this and find out what the other groups are doing so that we can align with.
Well, I personally don't see anything, but
Somehow my highest concern in the world is not the IETF progressing too quickly. I think that we probably still have time to well align the specs, but I could always be surprised.
I don't think we moved along this work too fast.
I think that we're making progress, but we need to, the token binding is having its first meeting tomorrow, and people should come. I think that it's composable with the stuff that we're doing and perhaps intertwined in some interesting ways, but like TLS, it's a tool that we can use to do different proof mechanisms. It's not a competing way of doing the tokens.
Justin Richards speaking from the dead microphone. Now, if you hold that up, I will actually project to that.
Yeah, fine. So what I was going to say is that, just to follow on John's point, I think it's actually more important that we sort of come alongside these other groups that are doing these bits and pieces and make sure that our work continues to be composable, and that none of us paint ourselves into any mutually exclusive corners unless we've explicitly decided to do exactly that. And so, no, I don't think the IETF will ever move too quickly for anything. I think that we can, there's a lot that we can do that can make sure that this moves forward appropriately.
Thanks, John. So, following up on what John just presented, I wanted to talk about one specification that talks about parameters that John mentioned on passing the keys from the authorization server to the client. And this is a specification, draft IETF Oauth Bob key distribution. And there are a few open issues that I would like to discuss in addition to the issue that John raised on the use of proof of possession for the access token in addition to the refresh token. Okay. Maybe you switch to this non-full screen. Yeah. That's better. You should switch to Windows, Derek.
You can run an ARM processor there.
Yeah. Okay, next slide. Yeah, I briefly wanted to summarize what the specification says, and then and give an overview on the summary, and then talk about the open issues briefly. Okay. So, so the specification, what it says is it defines a couple of new parameters and allows the client to sort of use those new parameters to request these proof of possession tokens, or request an access token that has these proof of possession claims that Mike was talking about earlier. And so the three new parameters in there, two of them are optional, or actually all three, is the audience element, the token type, and the algorithm. The token type and the algorithm are actually, the values in there are actually then defined by a specification that defines that specific client to resource server interaction, like the specification that Justin is working on with the signed HTTP requests. The audience indicates the resource server the client would like to talk to. That's needed because the authorization server, if you recall in the earlier discussion, if the authorization server encrypts or protects with a symmetric key the token, the access token, then it needs to know what key it shares with the resource server, because otherwise it wouldn't be able to do so in a symmetric key case. In an asymmetric key case, just with a digital signature, that wouldn't matter. But of course, with encryption, the authorization server would again need to know or select the public key of the resource server. So that's why there's this audience element in there. Okay, so that's the request. So those are the 3 new parameters in there. The token type refers to whatever that specific mechanism is, and consider the algorithm some supplementary information. One could combine the two as one field. That's possible, but I think nobody made the suggestion so far. So, okay, next one. So, and the authorization server, in response to it, if it understands that specification, it creates this proof of possession enabled access token, as we discussed earlier in Mike's presentation. And so it just has this claim in there. That's all. Next slide. And it sends that specific JWT then to the client. So that's the first response. So that needs to, that's already specified. The access token or the delivery of the access token is already specified in a base OAuth protocol. This is just this new parameter. The client, it's opaque to the client. The client doesn't need to understand the access token. So that's why there's no change to the specification from the client side point of view. However, the client also needs to know the key that is then later going to use with the authorization server. So, and if you listen to the discussion that that John just explained, there is the possibility. So there are two ways to do so. First, either the authorization server sends the key to the client. So this is transport layer security protected, this exchange between the authorization server and the client. So it sends that key, and that was the discussion earlier about this, about the JWK that is sent there. So you actually see the JWK being used twice, which John mentioned. Once is with the key that is meant for consumption by the client, and also within the proof of possession access token. What this slide set does not show, but John mentioned it, is if you have the case where the client actually generates an asymmetric key pair, this ephemeral key pair, and it's never meant to leave the client itself, the private key. Then the client needs to send, using the key parameter, needs to send in the initial request the public key or the fingerprint of the public key to the authorization server, because otherwise, because the authorization server needs to then bind that that public key into the JWT. But then it obviously doesn't need to send the key again, because the client already has the public key and the corresponding private key stored locally. So that's what it does. It's moderately complicated. So it's like Kerberos, but with the asymmetric version. So there's a little bit more complication, more things to think about. And specifically, when we go now to the next slide, when we talk about the open issues, so those are the fields that are the 4 fields that are defined in the specification that carry these parameters. Next slide. And then there are the open issues. And I should add the third one that was mentioned earlier about the refresh token versus access token, because currently the specification only talks about binding a key to the access token. It doesn't talk about binding the key to the refresh token, and that may be desirable. So that should be the third open issue. But the first two are, and I start with the simpler one, is so there are these algorithm negotiations, and that's a very common technique to just say, like, which algorithm do I want to use for with. So the authorization server tells the client what algorithm to use with the resource server, because the authorization server has this relationship with the resource server, so it knows what algorithms it understands. So at the moment, this is not a problem, because they are as the specification, just in specification, doesn't define that many algorithms, but in the future, if the new algorithms come along, there's this need to have crypto agility, or to provide the support for crypto agility already in the specification right now. And those, and these parameters could be registered as part of the dynamic client registration. So obviously one could actually reserve these fields in the specification already now, register those claims. And I think it makes some sense. It's just not in there, but I think it's a no-brainer. So that, the second open issue is fairly easy. That one is a little bit more tricky because currently the audience field just says, I want to, essentially, the client says to the authorization, so I want to use, bind the access token with the key for use with one specific authorization resource server. And if you use a public key crypto system, then you could actually use it with multiple resource servers. And the question is, do we want that? Without actually having to go, of course, the client could always, for example, present the same public key to the authorization server that it binds to the key. So you could, of course, do that as well. But basically in one shot, and I'm not sure about whether that sounds to me like an optimization, and I'm not sure whether we want to go in there. But I don't know. It would be good if people could have a look at this and see whether they have some use cases where they need support for this functionality.
So Hannes, currently in this, John Bradley thing, currently in the spec, if you're using asymmetric keys and you don't put an audience in, which audience is optional, then any of the resource servers that you might choose to use that, the resulting access token at, would be able to deal with it because it's a public key, it's asymmetric. All the resource servers would be able to validate it. You don't really need to have a list of them. The only reason to have a list might be in some perverse symmetric case where you wanted to encrypt multiple keys across multiple authorization servers, and I think that is an optimization that's a step too far. Just do it one at a time.
Yeah, and that's the reason why it's not in there, because there was no need so far, but we somehow marked it as an open issue because someone raised it, and so we added in there as a question. I haven't heard anything else since then. And to figure out what changes we need to make to also have the POP functionality for the refresh token, I think we need to sit together during this weekend to figure this out, what the implications are. Justin.
This is Justin Richard. Just to comment on that, we'll have to keep in mind that we would effectively be defining a new grant type for a POP-protected refresh token, and also we would be changing, potentially changing the response from the token endpoint in order to get the keying information that's associated with the refresh token, because we can't assume that it's the same key that the access token would be tied to in all the various cases. So yeah, it's a fair amount of surgery to make that happen, and I think we just need to keep that in mind if we decide we want to do that.
Have we had the use case discussion for POP protected refresh tokens? Okay, I'd want to understand that before we just dove in and acted like engineers, which we are.
Yeah, sort of the way how it currently works is it at the time when you get the access token, you get the key that is bound to that token, and so the question is then, what happens if you issue a new? If you get the refresh token and then you request a new access token based on that refresh token, to what is that key that you initially got or used, to what is it bound to? So if you request new access token and assume, so the case is, what happens if someone steals your refresh token and just use it because it's essentially a bearer token? And we don't want, the idea was that we don't want to open up holes so that the proof of possession is supposed to provide better security guarantees, but then an attacker just doesn't go for the access token, but instead he goes for the refresh token, uses the refresh token to mint new access tokens, and then he gets the key out of the box, and then he basically circumvents the whole security. that may not be possible in the current specification because he wouldn't get a new key, but
So in order to not let somebody reuse a stolen refresh token, they only get the key when in the code exchange. So when the refresh token is initially minted, you get a key if you're actually getting one. So when you use the refresh token to get access tokens, you don't get the new key. You don't get a separate key for each access token. If we wanted to push the keys down to a finer level and have like Oauth 1 point, if you want to have per token symmetric keys, then you have to do something to protect the refresh token. Otherwise, the interception of the refresh token, like in previous version of OAuth, sort of defeats the whole proof of possession mechanism. So we can either do key establishment with the exchange of code, or with the exchange of the refresh token. If we're doing it based on refresh token, then you have to do something to better secure the refresh token.
This is Brian from Ping. I'm not entirely sure how valid a use case it is, but it seems like there might be utility in POP protecting the refresh token and allowing access tokens to remain bearer tokens, just from a deployability and scalability standpoint. Maybe.
Right. So there is a different way of, outside of the OAuth proof of possession spec, there is a proof point that a mobile OS vendor has done where they're using a pre-standard version of token binding to bind the refresh token, which is completely opaque to the client. The client has no idea that it's going on because in the same way that you would token bind a session cookie, you could do the same thing to a refresh token without the client knowing anything about it. So some people are doing that now.
Chairman Bill Mills from Jabber. Proof of possession refresh tokens protect against RS compromise. Thinking about this, it's not clear what the benefit is for the proof of possession refresh tokens.
yeah, that's a good point, because in the initial discussion about why we introduced these proof of possession tokens, the main concern was that resource servers would actually, obviously, they get the bearer token and they could reuse that bearer token maybe in other places if that the same token is used for other places. Now, in this specific discussion, the threats are somewhat different, because here we are trying to go to a solution where you, ideally, in the best possible case, you generate these public-private key pairs locally on, let's say, a hardware security module, and the private key actually never leaves that module. And so you obviously want to then have protection, sort of deal with a sort of partially trusted client where, for example, the operating system may get compromised or the browser gets compromised, but then you still can't get to the secrets that are stored in that hardware security module.
If you're proof of possessioning the access tokens based on a key in the TPM, then you're pretty much done. You don't need to worry about the intermediate step of protecting the refresh token, because all of the access tokens would be protected by that key, unless you're using symmetric keys for that.
And in addition to that, if you have access to a key generating TPM, you can use that for client authentication as well, which is, unless you're a public client, going to be used alongside of the refresh token to validate that call back to the authorization server. So there are other patterns and issues here. Yeah, just sort of a related issue Bill wanted to bring up, if the secret storage is more secure than the token storage.
Right. So there is dynamic client registration, which once you have unique key material, then you have to decide whether you're, Do you actually want to have a separate client ID for each instance of client and dynamically register it, or use that key as in a Pixie-like way for proof of possession? So it's different ways that you can mix and match it. I knew it was going to bring Phil up.
I'm just, I got slightly distracted and I might be lost here, but sorry, who am I? Phil from Oracle. Okay, if we have a client proof of possession, so the client authentication is done with a hardware module, did we decide there's still value in a proof of?
Client authentication.
I'm just saying, I'm saying, so there's three things we're talking about. Access tokens being bound, a refresh token being bound, and a client token being bound. And in the case of, client authentication. Yes, it's important to be pedantic at this point. So I was distracted because I was thinking through the proof of possession for the refresh token and was thinking, is that adding value if the client authentication was demonstrating proof of possession at the same time? There is, just to back up a little bit, I was excited by this because if you issue a relatively simple bearer token for the resource access that's short-lived, then your risk is very low, and but you still might care enough that you want during the refresh process to have some form of proof of possession demonstrated each time, because you might be doing that a little bit more frequently to make the resource access simpler. So I was tossing around, is it that important that the refresh token itself have a proof of possession if the client is already demonstrating proof of possession in its authentication as part of that same exchange? I was just trying to understand the difference.
This is Justin. So I think that what it boils down to is that there's a large matrix of options and ifs and whatnots here. And like one of these corner cases is, what if we have a public client that can't authenticate itself, that gets its refresh token stolen, but has proof of possession access tokens? What do you do? And so that is one case where a proof of possession protected by a server-generated key refresh token would help that one part of the matrix. I think what we might be missing is a view of what all of the different optionality is here, because I think just about everybody that's gotten up to the mic has brought a different model of these different pieces to that. So what Phil was describing, what Brian was describing, what John's describing, what I'm describing, we've got different flags set, I think. And I think that might be confusing the overall productive conversation of what we actually want to solve here. Now, I am not saying we should build a requirements document or whatever like that, but I think that in doing this, we should at least push out what that matrix looks like.
I think it would definitely be helpful to add some additional text about the thread discussion on what the difference is between having what we currently have in a document, which is binding the key to the access token. What is different to the other alternative where you also have the token bound to the refresh token, without actually going there? Because so far we didn't see the need. We discussed it earlier and we dismissed the idea fairly quickly, presumably because we didn't saw the use cases, but we saw the complexity coming along. And I think maybe we haven't done such a great job in documenting those type of things.
But we do have dynamic client registration, which is almost done, which allows you, if the client does actually have a key, you can do dynamic client registration, turn a public client into a confidential client, and that protects the refresh token. But the downside of that is that you wind up with several billion client IDs, which has pluses and minuses, but you can also do that statelessly. So, as long as you don't do management, yes. what it's less likely that you're doing management for a native app, but, so, there's sort of a spectrum of, do you establish a per client instance key pair and do it as client authentication? Do you do it with a whole by doing some sort of proof of possession for the refresh token, which is Pixie is proof of possession for the code, so you could essentially do similar sort of thing for the refresh token. And this morning we talked about doing it for JWT assertions. We also need a proof of possession mechanism for assertions where they're being passed through a third party. So yeah, we probably need to understand what the various options are, because we got a lot of them.
Hi, Phil here. I just wanted to echo Justin's suggestion about doing a quick matrix or whatever you call it, if anything, because if it makes it obvious that certain options are redundant, we can capture that and say, this is why we don't have refresh and token proof of possession, because it's duplicated over here. Not saying that that's the case, but if we can find out the redundancies, that'd be great.
Thanks for volunteering to write that down, Phil. Right, which will be in RFC requirements talk, because we do those now. All right. So one part of the whole POP architecture is HTTP message signing. Next slide, please. So this is basically a way to create a detached signature for an arbitrary HTTP request message. You could maybe do it on a response as well, but I didn't think that through. The draft as we have it now is largely unchanged from a straw man I wrote, I forget how many IETF meetings ago, but this is a very key part of the overall POP process, as we'll see in just a little bit. It really needs to be completely analogous to 6750, which is how do you create an HTTP request that is tied to a particular token, an OAuth proof of possession token that was handed to you in order to make a call to a protected resource. We haven't done that exact part in the draft yet, because it's just a matter of defining the authorization header and the query parameter and the form parameters that we want to call it. The actual mechanism would just be reusing a lot of work that's already been done in Jose. Next slide, please. We've been talking about why we actually need to do this all along. Once you are proving possession of a token, it would be really, really nice for you to be able to actually protect the call that you're making. This is in addition to TLS. It's kind of a belt and suspenders approach in a lot of cases, although it could arguably be used without TLS if that fits your security deployment as well. And really, and this is, to me, one of the more embarrassing things, we could do it one version of the protocol ago, but we can't anymore. And so this is a very glaring regression of functionality. And it was a very well-used piece of functionality in OAuth 1.0, as broken as all of the signing crap in 1.0 was. Next slide, please. So, how does the sucker work? Oh, we have a jabbery thing.
Bill wants me to ask the obvious question, which is, HTTP signing, is this what the token binding working group is doing?
No. So what it actually is, speaking of segues, instead of binding to the TLS session itself or any part of kind of the lower layer of the connection, you're actually binding to the HTTP message itself. So in order to create this request, what you're basically going to do is look through the HTTP request that you're about to send across the wire. Look at things like your query parameters, your header, your URL, body, host, port. Figure out which bits of those you want to sign. You combine and hash these values in a deterministic manner, and then you list out what you signed. Then you put everything inside a job. So all of the hashes that you generated, in addition to the list of the things that point to the things that you hashed, put all of those inside of a JOT and sign the JOT with your key that you got through token possession, and then you send that JOT to the RS alongside the public portion of your proof of possession token from the authorization server. Next slide, please. If you're an RS, you get the JOT on the way in, you parse it, you validate the JOT's signature first and foremost, and figure out, using various mechanisms to actually look up the key that's supposed to be associated with this JOT. First, you figure out if that signed JOT is actually valid. So if the signature on the overall JOT envelope is invalid, you can chuck the whole thing right there. There's actually a second step to that, and that's that you pull apart the body, the payload of the JOT, to find out what was hashed on the incoming message. And so that'll tell you which query parameters were hashed and what the hash value was, which headers were hashed, and things like that. So to be clear, because I'm not giving a concrete example, I was careful to write it in such a way that you didn't have to reorder the parameters or depend on any particular ordering and stuff on the way in, and it is not as robust as it could be. It is absolutely not. It needs to have more people hammer on this draft. But one of the things, as you know, I developed a whole crapload of OAuth 1.0 code, and I freaking hated that incoming normalization of getting all the parameters in the right order and all of that stuff, because I was developing on a lot of frameworks that insert headers, that insert query parameters, that do all of that other stuff. And so the mechanism inside this draft is actually robust against a lot of that. Not universally robust, it's not perfect, but it's a lot better than, it's a lot less fragile than the OAuth 1.0 version of this, because it's very explicit about what was signed, or what was intended to be signed, at least by the client. So you go through that, you regenerate the hashes that are indicated in the JOT body, and then compare the hashes to the ones that actually came across the wire in the JOT. If they match, and the components of the HTTP message that you care about being protected were protected, that's an important extra check in here, then you're happy. Because the overall signature matches, the hash matches, and the stuff that was protected on the way in is what you expected it to be. So, next slide. Right, so this is why we did it this way. It's, so one, we don't have to screw around with the original HTTP message at all. There's no like special ordering of parameters. There's no armoring of the HTTP message. So I've seen a couple of people, a couple of cases where you take kind of the entire HTTP message and put that inside of a JOT and sort of make a generic HTTP message on the far end. And all of the stuff about what you're doing is inside the JOT, which is great because it's protected, but it's horrible because you can't reuse any HTTP processing mechanisms on the far end. You basically have reinvented SOAP, but with curly braces. So we wanted to very much avoid that. We didn't want to duplicate the original HTTP messages by pulling in the values, which is why we have the sort of the reference-based hashing mechanism there. And we wanted to be very clear about what was signed and what wasn't signed on the way in, so that you can work in cases where you have header injection, where you have parameters that get reordered and URIs that get redirected. Because if you're calling a resource server that you know is going to do some of that on you, you can avoid signing the pieces that you know are going to get screwed up. And if you are a resource server and you know that you're going to be messing about with certain types of things that's going to screw up the hash calculation, you can decide to process that in a way that's opaque to the client. So I think it's very, very flexible to do it this way. Next slide, please. So the thing is that this is not actually all that new. The specifics of how I've suggested we go about doing this are new, but this idea has been around for a long time. OAuth 1.0 did something very similar in protecting that. AWS has its own signed HTTP messages specification out of Amazon. There have been a couple of others that have been floating around. So it is a question of this working group. Do we want to just co-opt one of those? Do we keep going with the current proposal? Do we try to, you know, reboil another ocean? What are we going to do here? And my biggest question is anybody willing to actually help really fully build this out? I've poked around with it a little bit just to see the feasibility of pulling the different parameters and stuff off of an HTTP request message on a couple of different platforms, but we don't have any full implementations of this. So that's all I had, I think. Yes.
Any reaction
If you've looked, what are the semantic deltas to the Amazon proposal?
So one of the deltas, as I understand it, is that ours is a little bit more robust against all of the various injection and reordering stuff, as opposed to the Amazon thing, just because of the way that we've structured the information about what was signed and how it was signed. But not a ton of difference between the two. They are very similar because honestly, we're getting down to a point where this should be a very mechanical thing, and you know, a hammer is going to look like a hammer. I have not done a deep comparison, though. I will say that.
Could you have, is someone willing to do some reviews of the document to see where we are with that work? I think would be very useful. Anyone here not speaking? Brian, could you do that? Could you do?
Anyone else?
I was going to ask, can you get the Amazon authors to review it? To see if it meets their use case.
Well, just have a look at it, review it, and see where it fits. And yeah, I can ask them some of that.
Okay, that would be good. I'm not sure who on the AWS team was involved with that. Well, we'll see some of them in 2 weeks, but whether it's the right them is the question. Point.
Now, could you also take a look at that document?
All right, thank you.
I also think in the back of my mind, Mark Nottingham's doing something like this. I could be completely wrong, but it wouldn't hurt to get his eyes on it, probably.
So, I mean, the basic rundown is that this needs a whole lot more eyes and hands on it.